Yeah friends, this is Nikhil Nakka. So in the last video we have seen regarding power system syllabus. Now next comes one of the important core subject apart from power system, that is the electrical machines in the core subject. It is one of the core subject in electrical engineering. Power systems and machine together form almost like 40% of almost every competitive exam paper, starting from a state level paper or JE, SSC JE or RRB JE, wherever the technical part is involved. And when coming to gate examination, exams like gate examination, the electrical machines have got the highest weightage, and next comes the number one ranking of weightages for machines, and then it is for power systems. So definitely power systems and machines make the major part of any competitive exam for that matter. So it is very important to understand what are the different topics that we will be dealing in electrical machines. Hence, this detailed syllabus analysis video is presented for you. So just look at this word. This says that it is an electrical machines. Now primarily what we are concerned is about a machine. अब देखिए इधर ये machine का जो word है, इसमें एक word है which is called as a Mach, which means in Greek or Latin language it refers to mechanical motion. It refers to some motion. So mechanical energy is associated in a device called as a machine. Now this is an electrical machine. That means there are two energy associated with this machine, that is electrical machine and mechanical machine, electrical energy as well as mechanical energy. So in general जो machine होता है इधर वो एक डब्बा होता है. कौन सी डब्बा? Which looks like this. This is a डब्बा which is called as a machine. An electrical machine is that machine. अगर इस डब्बा को हम electrical energy जो input देंगे, then it will give you out the mechanical energy as output. Every machine for that matter will have an input level and output level. अगर हम input level में electrical energy लगाएंगे, at the output end you will get mechanical energy output. And if on the input end, if you apply mechanical energy, this machine will produce electrical energy and the output, isn't it? That means, okay, this electrical machine जो है, it will convert electrical energy to mechanical or mechanical to electrical. Hence, an electrical machine is called as electromechanical energy conversion device. In this first case, when it converts electrical to mechanical energy, you call this fellow as a motor. And in the second case, when this converts mechanical energy into electrical energy, this fellow was called as a generator. Okay, so motors and generators together called as electrical machine. अपने electrical machine में electrical energy input is available in two forms, that is AC and DC. Hence you have AC machines and then you have DC machines. So that is where we have this called DC machine, because this is a machine which can act as a generator or electrical generator or motor, but the electrical energy which is there, it will be available in the form of a DC. Okay, next comes the AC machine. So AC machines are again two types, induction machine and synchronous machines. So these things we will discuss later. Okay, so this is in general about an electrical machine. So from where the hell did transformer enter into the machine subject? Do you think a transformer will have any mechanical thing associated with it? No. What is a transformer? Even transformer is a dabba. What does this dabba does? If you give electrical energy input to this dabba, this will also produce electrical energy only as the output. The input level and output level both are electrical. But what is the difference is that the characteristic of that particular electrical energy is altered. The characteristic like voltage and current. Specifically, the voltage and current are changed. For example, if you call this a step-up transformer, it will increase the voltage, parallel it will reduce the current. Like that. So transformer is basically an electrical to electrical converter. But a generator or motor is an electrical to mechanical or mechanical or electromechanical energy conversion device. So there is mechanical energy associated, hence I can call them happily electrical machines, whereas I cannot call a transformer as electrical machine. But very often you study them together. You call transformer also as a part of electrical machine. But anyhow, for the sake of simplicity, I am including here a transformer subject in electrical machines main topic. But basically transformer does not belong to electrical machines category, but rather this is a static device. It is a static electrical device. It is just a static electrical device. Okay, this is a static electrical device. Acha, okay, be it a transformer or a machine, a machine which converts electrical to mechanical or mechanical to electrical, vice versa, or a transformer which converts electrical to back into electrical only. But how does this kind of a conversion takes place basically in this machine, in these both devices? This is a rotating device, this is a static device. In fact, both of them are devices only. Okay, so how does one form of energy gets converted into another form of energy in case of a rotating machine, and how does electrical energy converts into electrical energy with some change in qualities or some characteristics like voltage and current in case of a transformer? Basically there should be some link between this input stage and output stage. ये जो input state and output stage है, which is having different types of energy or same energy of different characteristics, इनके कैरेक्टरिस्टिक्स को बदलने के लिए और टू चेंज द फॉर्म ऑफ एनर्जी यू रिक्वायर सम लिंक, सम ब्रोकरेज और सम मीडियम इज रिक्वायर्ड. So who is that medium means? Be it a transformer or generator, that link which converts the both energies on the both ends is called as the magnetic field. Okay, the magnetic linkage is the link between input stage and output stage, which will actually doing the energy conversion process in case of a machine or electrical characteristic transformation process in case of a transformer. So it is very important to understand about magnetism also when you are studying about electrical machines. Okay, see, more the magnetic field, okay, more the magnetic field you have, higher the capacity of the device basically. Why? Because see, हम input में energy दबा रहे हैं. Okay, we are applying some energy from the input. From this energy to pass from input to the output, ये बीच में जो linkage है, the बीच में जो road है, a link which is connecting the input to output level, that should be high, isn't it? If the link is more energy can be applied input, more energy can come out as the output. So you tell me which factor in construction of any machine or a transformer will decide its capacity? The size of the magnetic field. Magnetic field is contained in magnetic system which is consisting of core. So the size of the core or the quality of the magnetic system determines the capacity of that particular machine. By meaning magnetic field, what do we mean by saying magnetic field? It is basically the concept of flux. The more flux you can produce in a machine, the more is the capacity of the machine. Now the flux of the machine, you know, is proportional to the V by F ratio, applied voltage by applied frequency ratio. Okay, that means the operation of the electrical machine or an electrical device like transformer is very much dependent on the system voltage and system frequency. The operation of these devices as well as the capacity of these devices is primarily or very sensitive to the changes in voltages and frequency. Hence, that is the reason why I was telling in my last lecture when I was discussing about power systems. In power systems, I was telling there are two factors mainly, voltage and frequency. They are commonly known as power quality indices, which will determine the quality of the power. If the voltage and frequency are not in control, if the voltage and frequency are not within standard, or they are not properly maintained or not properly analyzed and properly taken care of, that will ultimately affect the entire devices which are present in the power system. Now you take a power system. Power system means what? Power system primarily consists of a generating station and a load end. Okay, ये generating station and load end को link करने का जो line है वो transmission line है. In a transmission line, what is the major equipment in a transmission line? Transformer, because at the generating end you will generate at some low high voltage like 11 kV, 15 kV is the generating voltage. But to transfer this large bulk amount of power to large distances, this 11 kV is not enough. Therefore you have to step it up to 220 or 400 kV, 765 kV according to the amount of power to be transmitted and length of the line and power requirement. Hence you have to step up. Therefore transformer forms a very important form in a very important aspect of bulk power AC transmission system. Nowadays our entire power system is a bulk power AC transmission system. Hence transformer is a very important link. It is like a very important link in the entire power system operation. So you cannot neglect or you cannot compromise on the operation of a transformer. At the same time हमारा जो भी electrical energy generated हुआ है, why are we generating this much electrical energy? We are generating this much electrical energy to supply to the load. ये जो पूरा power system है जिसके ऊपर ये पूरा energy selling business चल रहा है, who is the major consumer of electrical energy? Is the industrial बोले तो motoring load. more than 70 to 75% of the total electrical energy generated is been consumed back by rotating electrical machine. What is that rotating electrical machine? Which will take electrical input? Motor. So the majority, 75% of the load on the power system is a motoring load. So do you think, and say me, what does this transformer, which is the important part of the power transmission system, as well as the motor, which is the majority of the load connected to the power system, depends on? It depends on the quality of the magnetism maintained inside that machine, which is nothing but the flux, which in turn depends on voltage and frequency. If your voltage and frequency are not properly maintained, do you think the entire power system will operate in satisfactory manner? No, you don't have that case. So it is very important to understand the importance of voltage and frequency as well as the magnetic design of electrical machines. Okay, so this is to just emphasize the importance of electrical machines and different machines in an electrical power system. Okay, because nothing is not important, everything is important in electrical engineering. Okay, so in this particular topic, so this is just to discuss about, the basic principles behind electrical machines and all. Okay, so what is the thing that we will be discussing here is, so electrical machine means basically there are two types, static devices and rotating machines. So static devices में जो एक ही आता है, that is a transformer. It has no connection with a machine. Transformer is an independent device which will convert electrical energy, okay, back into electrical energy with some change in characteristics. So to convert from electrical to electrical, बीच में जो link होता है, that is a magnetic system that we have seen. So I can say transformer converts electrical to magnetic and magnetic back into electric, isn't it? So transformer is an electromagnetic energy conversion device. Okay, it is an electromagnetic device. Okay, whereas all the electrical machines, they convert either electrical or mechanical energy into magnetic energy and magnetic back into electrical or mechanical. Okay, so this is an electromechanical energy conversion device. Electromechanical energy conversion device. Electromechanical energy conversion device. So हम transformers के बारे में discussion करेंगे. पहले, in the first hand, we will be discussing about transformers. Although explicitly not mentioned, we will also discuss about magnetic design. So because any electrical machine, you cannot neglect understanding about the magnetic properties, types of magnetic materials, and how does that magnetic system behave under different voltage and frequency ratio conditions, V/F ratio conditions, and all such matters. Okay, in transformers primarily the topic is divided into basically three categories. One is basic details. Okay, basic details of transformers will be there in this topic, and again you will study about three single phase transformers and three phase transformers. In basic details you will be just understanding the basic aspects, the like constructional aspects, magnetism, magnetic principles associated with the transformer, as well as we will also study about ideal transformer and practical transformer and equivalent circuit diagram. Once you up to equivalent circuit diagram, your basics are built along with formation of vector diagrams. Then we will be studying about single phase transformers, parallel operation, testing of transformers, testing of transformers, parallel operation of transformers, such kind of aspects, and some numericals, EMF equation, so on and so forth regarding single phase transformers, as well as the presence of harmonics, the effect of harmonics in single phase transformer. How does harmonic, third harmonic, effect of third harmonic, etc. This kind of topics will be discussed in single phase transformers. And then comes the important aspect, that is studying about three phase transformers, because our power system is AC power system. AC means how many phases? Basically three phase. The majority of the power lines, AC lines, are of three phase, and hence the transformers are also of three phase type. So it is very much important in a practical scenario to understand very well about three phase transformers. So what are the different types of three phase transformers as per Indian standards and Indian standards or British standards and American standards? A small difference. And how do we represent, how do we classify three phase connections into some vector groups? What are the different types of vector groups? How do you identify by looking at that connection diagram whether which kind of vector group does it belong to? Okay, that is one aspect. And again, effect of harmonics in three phase transformers, such kind of aspects, and as well as different types of connections in three phase transformers, like Scott connection, TT connection, okay, open delta connection. This forms very important aspects. And finally comes auto transformer, as well as did not specifically mention parallel operation of transformers. See, everything is very important. There is nothing like you cannot neglect this kind of thing in case of transformer. Okay, So transformer is also having a good weightage in almost every competitive exams wherever you have electrical machines. Okay, after we complete the transformers in a perfect manner, then immediately we will jump into this topic called as basics of rotating electrical machines. So basics of rotating electrical machine means, see, it is a rotating electrical machine. ये electrical machine क्या है? Electrical machine, it is an electromechanical energy conversion device. So ये जो electromechanical energy conversion device है, which converts electrical to mechanical or mechanical to electrical, the basic constructional and operation principles are the same, but the way you arrange certain aspects or the type of electrical energy you apply classifies them into DC machine or AC machines. Okay, so we will be discussing the aspects which are common to all the electrical machines in this topic, like constructional aspects. What does the constructional aspect have? Because I am telling this is a rotating electrical machine, definitely there should be one rotating membrane. Okay, there should be one rotating membrane. If one membrane is rotating, ultimately the other membrane should be static. So you have a stator and rotor which will be rotating inside a stator. You will have a stator, a cylinder, okay, which is fixed, and inside you have a rotor which is rotating. Okay, so what are the different types of materials used for stator and rotor, and constructional aspects, as well as the windings, different types of windings. Okay, we will be extensively discussing about windings in this topic mainly, and types of magnetic materials and construction types, etc., so on and so forth will be discussed in basics of rotating electrical machines. Okay, because these are the things which are common to all electrical machine. And then we will jump into DC machine. In DC machine we will be studying things which are specific to DC machine, like operating principle of DC machine. Okay, DC machine, okay, like we have in DC machines, machine means can be a generator or a motor. So we will discuss about DC generators as well as DC motors. So one important aspect about DC machine is the commutation. Okay, it is the commutation which is very important aspect in a DC machine. Okay, because it is a device called as a commutator which will differentiate a DC machine from a normal AC machine. Okay, therefore it is very important to understand about DC machine and a commutator. Okay, commutator action in DC machine and whatnot, many things to be discussed in DC machine. And also speed control of DC machine, especially a DC motor. Different types of tests performed on DC machines, generator and motors, this kind of aspects. And then we will jump into induction machine. So induction machine is also a machine which can be an induction motor or an induction generator. But there is one common thing between induction machine and a transformer. The thing is that transformer, as you know, is a two-winding machine. Okay, it is a two-winding device. It has an input winding and a secondary winding, or at the output end you have another winding. What an induction machine has is, it has a fixed primary winding, but the secondary winding, like which we have in a transformer, is now on a rotating membrane. Now it forms a rotating part. So unlike the other machines like DC machines or synchronous machine, induction machine has got some special quality. That is, the power factor of an induction machine will be poor as compared to these both fellows. Why is it like that? Why is it like that? Why? Because you see, I hope you are well aware about this fact that you are having DC machines, you are having induction machines or DC motors, induction motors, and as well as you have synchronous motor. Tell me which kind of motor is widely used in the industry? Undoubtedly, in one word you can say induction motors are widely used. The person who is self-made, who does not depend on somebody else, is definitely bound to success in life, bound to get success in life. You know, this is the fact of life, and this is the fact of life, isn't it? So when you talk about a DC machine and a synchronous machine, these both are well-off kids. They are having good background, family background, and they are having a lot of money and facilities. So whereas induction machine is a poor student, but he is a very hard-working student. The construction of induction machine is the strongest construction as compared to a DC machine and synchronous machine. Almost indestructible, unbreakable construction induction machine is having, and it is one of the rough and tough, least maintenance required machine, induction machine. And he is a poor guy, as I was telling. So I will tell you a small story. So there are three kids, DC machines and synchronous machines and induction machine. These both the kids belong to same category, they are rich people. Okay. So they are coming to college, these three people are coming to same college called RLC Academy. DC machine and synchronous machine parents are very rich. They have given them all the facilities. So they need not struggle in their life for their fundamental facilities of living. They need not, they need not worry about their basic facilities of life like food, shelter, etc. They, whatever the time is available for them, they can happily focus on studying and getting good marks. But whereas induction machine is not like that. He's a self-made kid. He does not have such kind of a background support. Now he has to work for himself to earn his living, as well as the remaining time he has to use for studying, which will actually ultimately fetch him success. So that is the problem associated with induction machine. That is, he is not having any background to support him. He has to use his energy, or he has to use his available time first to work, do some part-time job and earn some money and pay the tuition fees and study for the exam. Whereas these both fellows need not waste their time. They can use the entire time available for studying. Okay. Now what exactly I am going to mean is, see, this is a machine. The machine requires an input stage and output stage, which could be an electrical or mechanical. And बीच में जो important aspect which is making it the energy conversion possible from electrical to mechanical is magnetic system. So you require a magnetic flux to be produced. In case without magnetic flux, how much ever you rotate or whatever energy you may apply, this conversion does not take place, isn't it? How does a silly electrical energy directly converts into mechanical energy? It is obviously because of that magnetic system. So you have to provide magnetic system also, isn't it? So this magnetic system is itself is the background support which is given to a DC machine or a synchronous machine. In DC machine and synchronous machine, you are providing an external DC source to produce the required magnetic working magnetic flux. Whereas this बेचारा induction machine को हम कुछ भी नहीं दे रहे, खाली 3-phase input दे रहे हम. Now you see, this fellow has to draw the reactive power to produce the flux so that he will work, and as well as he has to draw the active power so that he can do his useful work. That is what he is meant for, doing the useful work. To do that useful work, he has to draw the reactive power. Now if the supply is providing him active power as well as reactive power, now tell me what is the input power factor to the machine? The machine power factor automatically falls down. Whereas if you take a synchronous machine, it is an AC machine, do you have to provide reactive power? No. Why? Because the reactive power requirement, why is the reactive power required? Basically to produce a working flux. Now he is having a facility, that is a separate DC source is provided. When separate DC source is available, why the hell he has to draw it from the supply? So definitely there is a chance that induction machine will operate at a very poor power factor as compared to a synchronous machine, isn't it? So that is the aspect about the synchronous machine. Okay. And synchronous machine is primarily called as a single excited machine, whereas DC and synchronous machines are called as, induction machine is a single excited machine, DC and synchronous machines are called as double excited machines. So such kind of things we can see in the course. Okay, now that is about induction machine. Okay, and then synchronous machine. See, study of synchronous machine forms a very important aspect as a power engineers. Why? Because now there is a general saying that the behavior of the head of the family decides the future of the family or the quality of the family. ये family क्या है कि उस family का जो head का behavior देख के we can understand the behavior of family members, isn't it? So now what family do I am referring to? The family which I am referring to is the power system family. ये power system कहाँ से शुरू होता है? From the generating station. Generating station means what? What is the primary device or the main device of a generating station? It is the synchronous machine, which is also called as a synchronous generator or alternator. The way the synchronous alternator or the synchronous machine behaves, it will determine the behavior of the entire power system. So it is very much important to understand about synchronous machine as a generator as well as a motor. So there are some special features. Because he is a rich kid, he is having many facilities, we can use the synchronous machine for variety of applications. So such kind of aspects about synchronous machines and types of synchronous machines, primarily based on the type of rotor, that is salient pole and non-salient pole type of synchronous machines are there. So different aspects about the synchronous machine and the effect of harmonics and the type of armature windings used in synchronous machine will already be discussed here in the rotating aspects. Okay, basic aspects of rotating electrical machines. So in brief, this is the detailed syllabus analysis of synchronous machines. Okay, and then apart from these machines, we will also discuss, it is very important for PSU exams, you have to know the application of each and every machine, DC machine and DC generator, induction machine and induction generator, synchronous machine, in synchronous motor and synchronous generator, different kinds of application in real world, which places do we use which kind of motor or which kind of generator and why. So such kind of aspect is very, very important. And the curves, wherever you find some curves, see, it may be mechanical characteristic curves or electrical characteristic curves, you have to remember the curve. So because there is a high probability that he will give you a curve and give numbers for the curve and try and ask you to identify which kind of a curve does this which kind of machine does this curve belong to, such kind of questions. And also there are some special machines like reluctance machines and single phase machines. Okay, these kind of fractional kilowatt motors, these kind of machines are also very important and their applications. Okay, so although not explicitly mentioned in this board, they will also should be covered in case of electrical machines. Okay, so that is about electrical machine syllabus analysis. Thank you for watching.